Hello everyone, this is Teacher Sam making simple matters. Our topic for today is rules of exponent. Again, rules of exponent. Let's have the first question. What is a exponent? This should be what is an exponent? Exponent, let's read together. Exponent is defined as the method of expressing large numbers in terms of powers. So exponent is making large numbers to make it smaller number, but we were going to use powers. For example, 6 is multiplied by itself 4 times. That means 6 times 6 times 6 times 6. So that's a large number if we're going to multiply it. Therefore, we can also write it in exponential form or in exponent form. That is written as 6 to the power of 4. So again, we can read it as 6 to the power of 4. Or that is 6 times 6 times 6 and times 6. So let's go over with the first rule, product rule. In product rule, it is important that the base of the exponents are the same. Again, we will call them this is your base and this is your exponent. That are the two parts of exponent. So what are we going to do? As you can see, we are just going to copy the base and we are going to add the exponent. Let's have an example. For example, 4 power 3 multiplied by 4 power 2. We are just going to copy the base, that is 4 and 4. So this will be 4. And we are going to add the exponents. 3 plus 2, which is equal to 4 to the power of 5. As easy as that. How about if I say, or if I will write 4 to the third power multiplied to 2 to the second power? Can we do it? No, we cannot do 4 and 2 together and we're going to write 3 plus 2. This is not correct. But here we can make some changes for 4 or we can also make some changes to 2. So let's have first changes in 4. So this other method will also be introduced to the next rules, but let's have a recap or let's have a forward for this. So 4 is similar with 2 times 2 or 2 to the second power. So 4 to the third power, if 4 is equal to 2 to the second power to the third power, this will be another rule later. That's product of the product rule. This will become 2 to the power of 2 times 3, which is equal to 2 power 6. Now, if 4 power 3 will be changed into 2 power 6, multiplied to 2 power 2, therefore we will have, correct, this will be 2 to the power of 6 plus 2, which is equal to the power of 8. But as I said, we can also use or some do changes for number 2 in here. That is, what is 2 to the power of 2? Means 2 times 2, correct? And this is equal to 4. And if a number have no exponent or you cannot see an exponent, it is not 0. It is 1. So we will have 4 to the third power times 4 to the first power, which is equal to 4 to the third plus 1 or 4 to the fourth power. So if we're going to check, this will become 4 times 4 times 4 times 4, which is equal to 64. Same here, which is 2 times 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 2, which is also equal to 64. Okay, let's go to the quotient rule. Okay, for product rule, there should still be the same base. This is similar to quotient rule, only the difference is that in product rule, we are going to add the exponents. In quotient rule, we are going to subtract them. Again, in product rule, we are going to add the exponents. In quotient rule, we are going to subtract them. So for example, we have 4 power 3 divided by 4 power 1. This will become 4, excuse me, 4 to the third power minus 1. So this is 4 power 2. Or we can also write this in the fraction form. That is 4 power 3 divided by 4 power 1 is equal to 4 power 3 minus 1. And 4 power 1 minus 1, we are going to subtract to the number below. This is 1, or the exponent in the denominator. So 1 minus 1, and we're going to minus it as well on the exponent in the denominator. So this will become 4 power 2 over 4 power 0. Now, one rule of exponent is that any number with the exponent of 0 is equal to 1. So 4 power 2 all over 1, or just 4 power 2. Okay, so let's have another example. For example, we have 4 power 5 divided by 4 power negative 6. Okay, so this will become 4 power 5 minus negative 6. We are going to subtract the exponent, so we have to do 5 minus negative 6. Since they are both negative, we have negative times negative, it will become positive. So this will be 4, 4 power 2, 5 plus 6, which is 4 power 2, 11. Okay, so this is really simple. I hope you can understand it so far. Let's go to the next rule. The next rule is power of a power rule, which is already briefly introduced on the first rule, which is the product rule. Here in power rule, it is separated by parentheses. So we are just going to multiply them. Okay? So this will become a power to m multiplied by n. Let's have an example. 4 power 2 raised to 3. Okay? So this will become 4 power to 2 times 3 equals to 4 power 6. Okay? Again, let's say 9 power to negative 2 raised to 7. So this will become 9 power to negative 2 times 7, which is 9 power to negative 14. So very easy to understand, to remember. Those the first three basic rules of exponent. We have product rule, we have quotient rule, and we have your power rule. Next is power of a product rule is just a combination of power rule. It's that we are just going to distribute the exponent to the following bases. So for example, let's have 4a multiply or to the power of 3. So we are just going to distribute the exponent 3 to the two bases. So this will become 4 to the third power and 8 to the third power. How about if the bases here have their own exponent? For example, 2 to the third power, 4 to the second power, power to the fifth power. So this will become 2 to the power of 3 times 5 and 4 to the power of 2 times 5. So this will become 2 to the 15th power and 4 to the 10th power. Okay? Again, we're just going to distribute the exponent outside. Okay, if that is negative, we have to distribute negative 5 exponent. Okay, so let's say this is negative 5. So this will also negative 5, negative 5. So the answer will be negative 15 and negative 10. So that's the power of a product rule. Next up, we have your power of a quotient rule. It's just a combination. We're just going to distribute m to the parts of the fraction. Okay, it's your to the a and to the b. That is the same even if it's not in fraction form. For example, let's have the fraction form first. 2 to the third power over 6 to the second power to 4. So this will become 2 power 2, 3 times 4 over 6 power 2 times 4, which is 2 power to the 12th power over 6 to the 8th power. Similarly, this can be also 2 to the third power divided by 6 to the second power to the fourth power. We are just going to distribute it. Okay, so this will become 2 to the third power times 4 divided by 6 to the second power times 4. Similarly, this will become 2 to the 12th power divided by 6 to the 8th power. So that's the power of a quotient rule. Next, the exponent rule only means that any base that has an exponent of 0 is always equal to 1. For example, 7 power 0 is equal to 1. 0 power 0 is equal to 1. Again, any number where bases, let's say c power 0, this is still equal to 1. Next, we have your negative exponent rule. Again, negative exponent rule. Negative exponent rule means your exponent is negative and we are going to put it in a positive form. So, the easiest way to explain it is that we have just to move the base and the exponent into its opposite side of the fraction. So this one is over 1. We are just going to put this from numerator to the denominator. So if our negative exponent is in the denominator, we just have to put it on the top. Okay, for example, 1 over 7 power to negative 1. We just have to put that on top. So 7 power to 1 over 1. So multiply by 1 because that's your 1 from here. We're not going to reciprocate them, okay? We are just going to move the negative exponent to the opposite side so that it will become a positive form. Okay, let's say 2 over 3 power to negative 5. So we're just going to move it. So 2 times 3 power to positive 5 over 1. Okay, we're not going to move the 2 because the exponent of 2 is not negative, it is positive. So it will stay in there. The explanation here is that, for example, a power to negative 2, this is similar to a power to negative 2 over 1. And going back to the previous rule that any power to 0 is equal to 1. So we can write it as a power to negative 2 over a power 0. Now, we know that the lower number here is negative 2. So if we're going to subtract that, a power to negative 2 minus negative 2 equal to a power to 0 minus negative 2. Negative times negative will become positive. We will only have now a negative 2 plus 2 over a. Negative and negative will become positive. So 0 plus 2. So we have a power to 0 because negative 2 plus 2 is equal to 0. And a 0 plus 2 equals power to 2. And a power 0 is equal to 1. And then a power 2. I hope you understand the concept behind the negative exponent rule. Following which, we have the last exponent rule here, which is the fractional exponent rule. Well, this is just easy to remember as well. That is that your numerator will go inside and the denominator will go outside the radical sign or the radical symbol or root symbol. Let's have an example. Let's say 7 to the 3/4 exponent or to the power of 3/4. So again, we're just going to first write the radical symbol or the root symbol, which is here. And then we're going to put 7 as your base. Your numerator, which is 3, will go inside, and your denominator, which is 4, will go outside. So from 7 to the power of 3/4, it becomes the square root of the root of 4 of 7 raised to 3. I hope you understand this. Just make sure that you don't get confused of which of the fraction is going inside and which one is going outside. Typically, since m is on the top, we just can say in, and then downside will be out, the radical symbol. Again, this is Mr. Sam. I hope I made your math simpler.